Hello, my name is Dr. Gleisner, and I'm talking about the development of the periodic table, and that is one of my favorite subjects. But I'm going to try and keep it short, because in the specification here you can see that it is actually a fairly short subject. So before the discovery of protons, neutrons and electrons, scientists attempted to classify the elements by arranging them in order of their atomic weights. Now that has to be taken with a little caveat, because they established the order of the elements with respect to their proportionate weight. So, for example, if hydrogen is taken as 1, we would now say, well, hydrogen is H2, and therefore it has a mass of 2 grams per mole. And so they made a pretty good attempt, though. They decomposed some elements, measured the gases coming off them, and of course the first ones didn't find all of the elements, so there were some problems there as well. Although they found nitrogen, for example, but they didn't they couldn't decompose certain other salts and compounds. So it was all relative at the time. So let's not be too harsh about this, right? Science is a gradual process. And what you can see here is the Royal Society of Chemistry website on the discovery of elements. And you can play around with the slider here and put more and more elements discovered over time. And then you can see that pretty much the majority of elements were sort of discovered from the late 1700s, so the early, the late 18th century to the present day. And I think the most of the elements had been discovered sort of that naturally occur by sort of let's say the late 20th century. You can also sort them out by their discoverers like Davy and Berzelius and so on. And of course you don't get discoverers for gold and silver and so on, because they were discovered in ancient times, and we don't really know who discovered them, and they probably multiple people found them in the ground and or were able to refine things like copper in charcoal fires, for example. And then you can, as I say, you can look at the elements by discoverer or by year, but this is not really what we are going to talk about. What we are going to talk about is the history of it. And there's one name missing, which I will add later on. But the main, this is already more than you probably need to know, so this is going to be the long version of it. And I will probably cut that into a shorter version as well, the TLDR version. Okay, so we have on the Royal Society of Chemistry website, you can read that for yourself. But the essential idea is that as more elements were being discovered, then people had more puzzle pieces to actually put them into some sort of system. But the early discoverers, or the early development was done by scientists who thought that of their time, probably most of the elements had been found. And they started arranging the elements that were known and forced them into a sort of system. And that meant that sometimes elements were written into the same box in order to make them fit, or they were out of order because relative to their atomic mass or their atomic weight, they didn't fit into in with other elements. And so when Jean Courtois did that, he came up with something called the telluric screw, and that plotted the atomic weights of the elements on the outside of a cylinder. You can see it's like an old style Cody thing. If you take a pencil and you put like a bit of paper around it and you twist it, and then you can read one line and it gives you a message. And that kind of thing is what he came up with, and it already looks a bit like a periodic system, right? So you get the similar elements, or you get elements in the same sort of column underneath each other. Then John Newlands refined this a little bit, and he came out with something called the law of octaves. And he thought the one of the influences, of course, that you mustn't forget is religion still. So there were all sorts of mathematical and semi-religious, but also truly religious influences in there. And people were looking for patterns and for messages from from the creator, possibly. So Newlands didn't leave any gaps, and this is really where Mendeleev later on comes in. But before that, there was a guy called Julius Lothar Meyer, and he plotted this sort of graph. And again, you can see, if you take that as a line here, you can see these three elements are on a line, and then you can put various lines across there, and something is happening periodically. And so there is some sort of system here. To Meyer's credit, he later admitted that Mendeleev had published his version first, but it is very likely that they came up with the sort of similar idea together, more or less at the same time. It's just, one person had to publish it first, I guess. Okay, so Mendeleev's genius really was that he arranged not only the known elements, but he also left gaps in for elements that he felt were certain to be discovered. And he also predicted some of the properties. So, for example, gallium hadn't been discovered, and he called it Eka aluminium. So he then predicted some of the numbers, and all that he did was really he took the mathematical middle, maybe identified a slight trend, and adjusted up or down. So when that is compared with the actual melting point of gallium, that was a good success. However, he wasn't sure, and not all of the elements had been discovered. But this is the thing. If you know that there are gaps, you're more likely to look for something to fit the gaps. And so that was what spurred people on to discover more things. Henry Moseley was a scientist who actually used X-rays. So X-rays hadn't been discovered until that point. But he discovered that if you use X-rays and you fire them at certain elements, then you can get a certain pattern out of the result. And that pattern led him to a rule. The rule was that the frequency of the X-rays that were coming out, when you plot the square of that frequency against the atomic number, the graph shows a perfectly straight line. Now, when I say perfectly straight line, obviously plus or minus the measuring errors, but it was a real advance. And later on, people could then argue and determine how the X-rays scattered in that way. And again, that finding wasn't an end in itself, it led to more discoveries. So, you should basically focus on Mendeleev in this, but you should also appreciate that it was a step-by-step process, and that Mendeleev didn't have all the elements, but people that came before him certainly had fewer elements to play with. So don't be too harsh on them. They didn't get it entirely right. But Mendeleev's genius basically was to leave gaps, to turn some of the elements around that didn't seem to fit in terms of mass. And of course, now we know tellurium, iodine, or potassium, argon would have ended up in the wrong group if they had simply been ordered by mass. So the number of neutrons can go up as well as down. And that was what confused the issue initially. But after his death, there was no confusion anymore, and now we have the periodic table as it is. I'll see you in the next video. Okay, so some rounder on YouTube challenged me to teach people for free, so I'm doing that now. GCSE, A-level, chemistry, physics, whatever you like, let me know in the comments, like and subscribe. Thank you.